students. Today we start from cell. What is cell? A cell is a device used to maintain a steady current. Steady means constant. Okay? Steady current in a circuit is called cell. Okay? A cell has two electrodes. How many? Two electrodes immersed in an electrolytic solution. Okay? The pictorial representation of a cell is like this. Two vertical bars, one is of large size and another is of small size. The large size vertical bar is represent positive and small represent negative. Okay, now the battery. A battery is a collection of large number of cells. Once again, battery is a collection of large number of cells. They may be connected in series or in parallel. The pictorial representation of battery is like this. Okay. Now, the new topic, electromotive force. EMF. Before the invention of potential, electromotive force is the force that carry the positive charge from positive terminal to negative terminal. Okay, but after the invention of potential, it is defined as the potential difference. Once again, it is defined as the potential difference between positive and negative electrode in an open circuit. Always remember this. Potential difference between positive and negative electrode in an open circuit. Okay, that is EMF is represented by E is equal to V plus V minus. EMF of a cell is always greater than 0. Okay. Now consider a resistor R connected across the cell. Okay. A current I flows across R. A current I flows across R. When circuit is open, R is infinite. An open circuit offers infinite resistance. Then we know that I is equal to V upon R. According to Ohm's law, V is equal to IR. Then I is equal to V upon R. So, I is equal to V upon infinity because R is infinite. Then we get current I is equal to 0. Means in an open circuit no current is flowing. Okay. Then potential difference between P and N. Potential difference between P and N is V, that is equal to potential difference between P and A. P and A. Okay, that is V plus potential difference between A and B. Potential difference between A and B. But no current is flowing between A and B because the circuit is open. Then potential difference between A and B is 0 plus potential difference between B and N. B and N. Okay, that is V minus. Okay, ji. So V equal to V plus V minus this potential difference is equal to EMF. This potential difference is equal to EMF. That is, E is equal to V plus V minus, and this always greater than 0. Okay. Now terminal potential difference. It is defined as potential difference between positive and negative electrode in a closed circuit. Once again, potential difference between positive and negative electrode in a closed circuit. Okay, in closed circuit, R is finite. So I is equal to V upon R. This represents that I does not equal to 0. Okay, so potential difference between P and N is V equal to potential difference P and A. P and A, potential difference between A and B plus potential difference between B and N. So potential difference between P and A, V plus potential difference between A and B, that is minus IR. Why this negative sign comes? This is due to the direction of current outside is this and inside this, both are opposite. Okay, so the direction of current in electrolytic solution is opposite to the direction of flow of current in circuit. So we take negative sign plus potential difference between B and N, that is V minus. Okay, so V is equal to V plus V minus IR. Okay, but V plus V minus is EMF E. So V is equal to E minus IR, or E is equal to V plus IR. These are the formula during discharging of a cell or battery. Okay, now in case of charging, during charging, V is equal to E plus IR. Now the current is opposite, so negative sign becomes positive. Then during charging, always remember this, during charging V is equal to E plus IR, E is equal to V minus IR. Here V is potential difference, terminal potential difference. E is electromotive force. Okay, I is current, and R is internal resistance of cell. Okay, internal resistance, the opposition offered by an electrolyte and electrodes of a cell to the flow of current through the cell is called internal resistance. Okay, internal resistance depends on the nature of electrolyte and electrodes of a cell. Okay, we know that V is equal to E minus IR. The relation between terminal potential difference and EMF. According to Ohm's law, V is equal to IR. From equation 1 and 2, we get I capital R is equal to E minus I small r, then IR plus IR is equal to E. I is common, so I capital R plus small r is equal to E, and we get I is equal to E upon R plus R. If R is 0, then maximum current drawn from cell when R is equal to 0. This means external resistance is 0. Then I maximum is equal to E upon R. This is the maximum value of current drawn from cell. Okay. Now the determination of internal resistance, that is R. Okay. Now equation third, equation 2. Dividing equation third by equation 2, we get E upon V. E upon V equal to I R plus R upon I R. R. Okay. Then I cancel out. Then we get E upon V equal to R plus R upon capital R, or 1 plus R upon capital R. Now R upon R equal to E upon V minus 1 equal to E minus V upon V. Then internal resistance R equal to E upon V minus 1 into R, or E minus V upon V into R. This is the required formula of internal resistance. Okay.